this lesson, we're going to determine the multiplicity of zeros of a polynomial function when given its graph or its equation in factored form. The number of times a given factor appears in factored form of a polynomial is called the multiplicity. For example, here you see the factored form here of this binomial, and the m stands for the number of times that that factor appears, and that determines its multiplicity. Now, the number itself inside is the zero of the multiplicity, and to get that is just like solving for x, and whatever that equals, that is your zero. The sum of multiplicities is the degree of the polynomial function. So if you add up all your multiplicities within that polynomial function, it will give you the degree of the polynomial function. So for example, here I'm given the factored form of this polynomial, and I want to identify its multiplicity and its zeros, and then determine the degree of the polynomial. So starting with the first factored form, the x minus 6, so what is the zero? If you were to solve this for x, x would be 6, so 6 is a zero of this polynomial function. What's the multiplicity? How many times do you see x minus 6 appear? Only once, so that is its multiplicity. For the next factored form, what is the zero? When you solve for x, the zero would be 1. How many times at most does x minus 1 appears? And that would be twice, so the multiplicity there would be 2. The last factored form there of x plus 2, what is the zero? That's correct. It would be negative 2. And the multiplicity, yes, you got it, would be 1. Now, if we add up the multiplicity column, the sum of the multiplicities is the degree of the polynomials. And so that is why once we add that multiplicity column, we can see that this polynomial function has a degree of 4. All right, what is the degree of this polynomial? Well, let's take a look at all of the multiplicities of the factors. So if the first one, it has a multiplicity of 2, then you have a multiplicity of 3, and then lastly a multiplicity of 1. So 2 plus 3 plus 1 is going to give you a total of 6. So the degree of this polynomial is 6. Now notice 6 is an even polynomial. So it's either both ends are going to face upward like a rise, or both are going to fall. Notice we don't have any negatives outside in any of these factors, so that is a positive leading coefficient there, which means that it's going to be facing upward, just as you see on the given graph. Other things we want to know about this graph is in terms of its multiplicity. For odd multiplicity factors, it is going to cross the graph, and recall the multiplicity is, you'll see the little number up top. So with the factors that have an odd multiplicity, such as the x minus 3, and the x plus 1 also has a 1, that's an odd. What you're going to see there is those will cross the graph at that point. So notice there at -1 and at 3, it crosses the graph at that point. And then if your multiplicity is an even number, then it will just touch the line there. So it touches it, but it never really crossed the x-axis, just sort of touches it if the multiplicity is even, such as here x squared has an even multiplicity, and notice there at that point it just simply touches. It does not pass through or cross the x-axis. Here's another graph. So what is the degree of this polynomial? So let's take a look at the multiplicities. We have 2 plus 1 plus 2. That's a total of 5. So the degree is 5. 5 is an odd number, so that is one that's going to have an odd behavior of, recall the S shape. And again, the coefficient is positive, so it's going to be moving from left to right in an upward motion, like a rise, just as you see on the graph. Now let's take a look at the multiplicities, starting with the points to where it's going to cross. That would be at 2, because it's the only one there that has an odd multiplicity, and it is going to touch there with the right at the x squared there, with the quadratic there, and also at -3 at that point where that 0 is as well. Okay? Let's complete this table and identify all the zeros, the multiplicity, and the degrees of the given polynomial. All right, so what are our zeros? All right, so we have, remember, it's just a matter of solving for x. So the first 0 is going to be -1. The second one's going to be 2. And the last one is going to be 1. In terms of which ones cross, so recall the ones that cross are your odd. So that would be this first one and the last one. So at 1 and at -1 is where it will cross or pass through the x-axis. And then the even is where it touches, or it's going to touch at 2. What is the degree? Well, we just can add up the multiplicities. 1 plus 2, which is 3. 3 plus 1 is 4. So that would be a 4th degree polynomial. Let's move on to the next row. What's our zeros? Our zeros are -2 and 1. Where does it cross? So it's going to cross. There will be no points where it crosses because we don't have any odd multiplicities. Where it touch, it will touch at -2 and 1. What is the degree of this polynomial? So all we have to do is add their multiplicities to see that this polynomial is of 4th degree. Let's go on to the next row. What are our zeros? We can see it's going to be -1, 1, and 2. Crossing is going to cross at 1 and at -1 and at 2. So -1, 1, and 2 is where it's going to cross. It will not touch anywhere because we don't have any even multiplicities. What is the degree of this polynomial? Let's count their multiplicities. 3 plus 1 is 4, and 4 plus 1 is 5. So this is a fifth degree polynomial. Let's do the last example there. The zeros, there are going to be a 0 at 2, at 1, and at -1. It's going to cross at 1. It is going to touch at 2 and -1. What is the degree of this polynomials? Let's count their multiplicity. 2 plus 1 is 3, and 3 plus 2 is 5. So that is a fifth degree polynomial. And there you have it, completing a table of values, identifying the zeros, the multiplicity, and degree of given polynomials.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.